The purpose of this video is to revisit, or if you've never seen this before, introduce you to operations involving fractions. Before we get started, I want to speed through what we discussed in the last video. In the last lecture video, we went over the order of operations. We learned that we must first solve anything enclosed in parentheses. We then proceed to evaluate numbers with exponents. After that, we solve any multiplication and division found in the problem, and we finish up with addition and subtraction. Here are the answers for the practice problems. Feel free to skip ahead. Now that we've covered PEMDAS, we are now ready to go over operations done on fractions. There are 4 things I want you to remember. The first one is conceptual, and that is that fractions themselves represent division. Instead of the division symbol we see in early grade school, we use the bar to denote division. For example, 6 divided by 2 is written as 6 over 2. Notice that the numerator is the dividend and the denominator is the divisor. The second thing I want you to remember is crucial. You should never have a 0 in the denominator. Why? Because as I just mentioned, fractions are another way of writing division, and you should know that you can't divide by 0. If you are ever solving problems and you end up with a 0 in the denominator, at this level in your physics career, you can conclude that you probably made some mistake with your algebra, so be on the lookout for that. The third thing you should know is that there is always an invisible 1 in the denominator of every integer that you can make visible should you need to. Now, what do I mean by that? Consider the number 3. This can be written as 3 over 1. How? Well, let's do the division. 3 divided by 1 is equal to 3, and 3 is equal to 3. It's literally the same thing. Therefore, 3 is equal to 3 over 1. It's a bit circular, but I like to think of it as writing the same thing in a different way, or representing 2 sides of the same coin. If this was a bit confusing, don't worry. Just know that there is an invisible 1 in the denominator of every integer. Now you may be questioning, why on earth would we write any number like that? I'll show you in a minute, so keep this close in mind because it'll be useful. The last thing you should remember is that you should always simplify your fractions once you finish conducting your operations. You do this by dividing both numerator and denominator by a common factor, though you do save time if you instead use the greatest common factor. For example, suppose you end up with the fraction 24 over 64. You could say, oh, these numbers are both divisible by 2. You proceed to apply the operation, so your fraction becomes 12 over 32. But wait, these numbers are also divisible by 2. Now your fraction becomes 6 over 16. But yet again, these numbers continue to be divisible by 2. Now you end up with 3 over 8. The fraction has finally been simplified. However, a faster way to do this is by simplifying using the greatest common factor. In this case, you'd have to recognize that the greatest common factor is 8. 8 can fit evenly into both numbers. 24 divided by 8 is 3, and 64 divided by 8 is 8, leaving us with the same simplified fraction, but with way less steps. Let us proceed now to learning about adding and subtracting fractions. Whenever you're about to add or subtract fractions, the first thing you need to check is whether or not they all have the same denominator. If they do, then you proceed to perform the operation only on the numerators. Your resulting fraction will have the same denominator as your other fractions. However, that doesn't necessarily mean you're done. Remember that if you can, you should simplify your fractions after completing your operations. Now, what happens when the denominators are not the same? What we'll need to do is to multiply the denominator by a number that'll make it equal to the denominator of the other. Then we can apply the operation to the numerators. Let's go over a few examples to clarify the information. Consider the problem 2 over 2 plus 15 over 2. The first thing we do is take a look at the denominators. They are equal, awesome. This means we can simply apply the operation to the numerators. 15 plus 2 is equal to 17, so our final answer is equal to 17 over 2. The next problem is 8 over 9 minus 3 over 9. Denominators are the same, great. 8 minus 3 is equal to 5, thus our answer becomes 5 over 9. Now what happens when we get the following? 4 plus 3 over 9. We have a number without a denominator and another that does. This is where the invisible 1 comes in handy. You could write this as 4 over 1 plus 3 over 9. Now, of course, writing it this way, we can clearly see that they both don't share the same denominator. So what do you do then? In this case, you multiply the 1 in the 4 over 1 by 9. But when you do this, you must also do it to the numerator. Now this becomes 36 over 9 plus 3 over 9. Notice that they both share the same denominator. We can now perform the addition on the numerators, so our answer is 39 over 9. But is this our final answer? Not quite. This fraction has not been simplified. Both numerator and denominator are divisible by 3. 39 divided by 3 is equal to 13, and 9 divided by 3 is equal to 3. So our fraction becomes 13 over 3, and this is our final answer. Let's do another example. Say you're given 5 over 6 minus 2 over 3. These two fractions don't share the same denominator. In the previous example, we multiplied the 1 by 9 so that both fractions could share a denominator. Can we do something similar? The answer is yes. We should multiply the 3 in the denominator by 2, thus making it a 6. But remember that if you do so, you must also multiply the numerator. Think of it as, whatever I do to the denominator, I must also do to the numerator. After the multiplication, 2 over 3 turns into 4 over 6. Our problem then becomes 5 over 6 minus 4 over 6. They now share the same denominator. We perform the operation on the numerators, and our answer is then 1 over 6. Let's do one more. Consider the following: 9 over 4 plus 8 over 5. The first thing we do is check the denominators. We see that they're not equal, so let's proceed with the same process that we've been following, which is to multiply the denominator by a number that'll give us a new denominator that is the same as the other one. But which one do we multiply? In the previous problems, we had been multiplying the smaller one. But what number can I multiply the 4 by that'll give us 5? There isn't an integer that will do that. So listen carefully. In this case, what we must do is to multiply the numerator and denominator of both fractions by the denominator of the other one. We'll multiply the 9 and the 4 times 5. This fraction now becomes 45 over 20. Next, we multiply the 8 and the 5 times 4, and we get a new fraction equal to 32 over 20. Now it's clear why we did this. We end up with two fractions that share the same denominator. Our expression is now 45 over 20 plus 32 over 20. We add the numerators and get an answer of 77 over 20. Let's move on to multiplying and dividing fractions. From my experience, multiplying and dividing fractions are considerably more relevant to physics problems than adding and subtracting. But I felt that making a video discussing only multiplication and division would be incomplete. If you learn to multiply and divide fractions, you might as well learn how to add and subtract them. When it comes to multiplying fractions, things become a bit more simple. You simply multiply across. You multiply the numerator with the other numerator and the denominator with the other denominator. There's no need for them to share the same denominator. Let's go over a few examples. Consider the problem 2 over 3 times 4 over 5. As I recently just mentioned, you multiply across. Numerator times numerator and denominator times denominator. 2 times 4 is equal to 8, and 3 times 5 is equal to 15. The fraction can't be simplified any further, so this is our answer. The next problem is 3 over 7 times 14 over 9. We are going to solve this problem two different ways. The first method we'll follow is similar to the one we just used, though we'll end up with a fraction that needs to be simplified. The second method we'll use centers around a technique called cross-cancellation. I want you to focus on cross-cancellation because it's what's most commonly used, and in many ways it can be a bit faster. Let us then begin with multiplying across. 3 times 14 is equal to 42, and 7 times 9 is equal to 63. Our resulting fraction is thus 42 over 63. Are we done? Absolutely not. This fraction can be simplified. We now have to find a number that can fit evenly into both numerator and denominator. We would prefer the greatest common factor, but sometimes we just have to use what we know. For example, when I was in grade school, we were only taught multiplications up to the 12 number, So using the multiplications I know by heart, I can tell that 7 can fit into both numbers evenly. Therefore, we'll divide 42 and 63 by 7. This will give us a new fraction, 6 over 9. Are we done now? Not quite. Both 6 and 9 are divisible by 3. So we divide them both. 6 divided by 3 is equal to 2, and 9 divided by 3 is equal to 3. Our resulting fraction is 2 over 3, and this is our answer. Let us now use the second method, cross-cancellation. The method of cross-cancellation is similar to the first in that there is simplification involved. However, the simplification is done before we even multiply. We start off with the same problem, 3 over 7 times 14 over 9. To use cross-cancellation, we first take a look at the 3 and the 9. Ask yourself, is there a number that can fit evenly into both 3 and 9? The answer is yes. 3 and 9 are both divisible by 3. 3 divided by 3 is equal to 1, so we cross out the 3 and place a 1 next to it. 9 divided by 3 is equal to 3, so we cross out the 9 and place a 3 next to it. We get a new expression of 1 over 7 times 14 over 3. Notice how we replaced the yellow crossed out numbers with the green ones. Next, we take a look at the 7 and 14. Is there a number that fits into both evenly? Yes, 7 fits into both. 7 divided by 7 is equal to 1. We cross out the 7 and put a 1 next to it. 14 divided by 7 is equal to 2. We cross out the 14 and put a 2 next to it. This now makes the expression 1 over 1 times 2 over 3. You can finally multiply and cross and therefore get the same answer as before, 2 over 3. The next example problem is 5 over 6 times 9 over 10. We'll solve this problem both ways again. First, we multiply across. 5 times 9 is equal to 45, and 6 times 10 is equal to 60. Our resulting fraction is 45 over 60. Both of these numbers are divisible by 5. 45 divided by 5 is equal to 9, and 60 divided by 5 is equal to 12. Therefore, the fraction becomes 9 over 12. We can still simplify. 9 and 12 are both divisible by 3. We get 3 over 4, and this is our answer. Let's go ahead and now use cross-cancellation. We have the same problem, 5 over 6 times 9 over 10. The first numbers we look at are 5 and 10. Do they both share a number that can fit evenly in them? Yes, 5 can evenly fit. 5 divided by 5 is equal to 1, so we cross out the 5 and put a 1 next to it. 10 divided by 5 is equal to 2. We cross out the 10 and put a 2 next to it. Now our expression becomes 1 over 6 times 9 over 2. We look at the 6 and the 9. Do they both share a common factor? Yes, they are both divisible by 3. 6 divided by 3 is equal to 2. We cross out the 6 and put a 2 next to it. 9 divided by 3 is equal to 3. We cross out the 9 and put a 3 next to it. The expression now becomes 1 over 2 times 3 over 2. Multiplying across, we get the same answer as before, 3 over 4. Consider this next problem, 8 over 15 times 25 over 12. From here on out, we'll only be using cross-cancellation. We look at the 8 and the 12. These numbers are both divisible by 4. 8 divided by 4 is equal to 2. We cross out the 8 and put a 2 next to it. 12 divided by 4 is equal to 3. We cross out the 12 and put a 3 next to it. Now we look at the 15 and the 25. Both are divisible by 5. 15 divided by 5 is equal to 3. We cross out the 15 and put a 3 next to it. 25 divided by 5 is equal to 5. We cross out the 25 and put a 5 next to it. The expression is now 2 over 3 times 5 over 3. I want you to notice that there really wasn't a need to rewrite the expression. If you write cleanly and organized, you could simply multiply the green numbers across without having to write extra steps. I included, however, to make it clearly visible that that's what we're doing. Multiplying across, we get a result equal to 10 over 9, and this is our answer. Consider the following, 18 over 35 times 14 over 27. We look at the 18 and the 27. These numbers are both divisible by 9. 18 divided by 9 is equal to 2. We cross out the 18 and put a 2 next to it. 27 divided by 9 is equal to 3. We cross out the 27 and put a 3 next to it. Now we look at 35 and the 14. Both are divisible by 7. 35 divided by 7 is equal to 5. We cross out the 35 and put a 5 next to it. 14 divided by 7 is equal to 2. We cross out the 14 and put a 2 next to it. The expression is now 2 over 5 times 2 over 3. We multiply across and get an answer of 4 over 15. Dividing fractions is also not too complicated. It's pretty much the same process as multiplying fractions, but with a slight twist. What you must do is multiply the top fraction by the reciprocal of the bottom fraction. What the heck is that? Let me show you. You get the reciprocal of a fraction by simply switching the denominator with the numerator and vice versa. Consider 3 over 7. The reciprocal is 7 over 3. What about 5 over 2? The reciprocal is 2 over 5. And 8 over 9? The reciprocal is 9 over 8. You get the picture. Now then, let's go over some examples of dividing fractions. Consider the problem 2 over 3 divided by 4 over 5. We should first identify the fraction in the denominator. That is 4 over 5. What's the reciprocal of 4 over 5? 5 over 4. Now we multiply the fraction in the numerator with the reciprocal using cross cancellation. We look at the 2 and the 4. They are both divisible by 2. 2 divided by 2 is equal to 1. We cross out the 2 and put a 1 next to it. 4 divided by 2 is equal to 2. We cross out the 4 and put a 2 next to it. What about 3 and 5? These numbers do not share a common factor besides 1, so we leave them as is and multiply across. The resulting fraction is 5 over 6, and this is our answer. The next problem is 3 over 7 divided by 6 over 11. What fraction is in the denominator? It's 6 over 11. What's the reciprocal of 6 over 11? 11 over 6. Now proceed to multiply the fraction in the numerator with the reciprocal using cross cancellation. 3 and 6 share a common factor of 3, but 7 and 11 do not share a common factor other than 1. 3 divided by 3 is equal to 1. We cross out the 3 and put a 1 next to it. 6 divided by 3 is equal to 2. We cross out the 6 and put a 2 next to it. We multiply across and get a fraction equal to 11 over 14, and this is our answer. How would you solve this next problem? 5 divided by 9 over 4. Well, you do what we've been doing, which is to identify the fraction in the denominator. But in this case, that may seem a bit tricky, because we have 3 numbers instead of the typical 4. So, is the denominator 9 over 4 or just 4? Pause for a moment and think about it. The denominator is 9 over 4. There are 2 things that suggest this. The first one is the way in which the expression is presented. The 5 is enclosed with parentheses by itself, while the 9 and the 4 are in parentheses together, so they act as a single unit. This tells you the 5 is the numerator and the 9 over 4 is the denominator. The second thing that suggests this is how I read you the expression. I said 5 divided by 9 over 4. If I had instead read it as 5 over 9 divided by 4, then the 4 would be the denominator. Alright, so 9 over 4 is the denominator. What's the reciprocal? It's 4 over 9. We now multiply the numerator with the reciprocal. Remember that there is an invisible 1 underneath every integer. Can we use cross cancellation here? No, we can't. 5 and 9 don't share a common factor other than 1, and neither do 1 and 4. So we simply multiply across. We get a fraction equal to 20 over 9, and this is our answer. Let's proceed to the next problem. 8 over 15 divided by 16 over 9. I am going to go quickly through the next 2 problems, so I suggest you pause the video and attempt this yourself. 16 over 9 is the denominator. The reciprocal of 16 over 9 is 9 over 16. We now multiply numerator by the reciprocal. Can we use cross cancellation? Absolutely. 8 and 16 are both divisible by 8. 8 divided by 8 is equal to 1. We cross out the 8 and put a 1 next to it. 16 divided by 8 is equal to 2. We cross out the 16 and put a 2 next to it. 15 and 9 are both divisible by 3. 15 divided by 3 is equal to 5. We cross out the 15 and put a 5 next to it. 9 divided by 3 is equal to 3. We cross out the 9 and put a 3 next to it. We can now multiply across 1 times 3 and 5 times 2. We get a fraction equal to 3 over 10, and this is our answer. The last example problem is 18 over 35 divided by 12 over 7. Pause the video and give it a try. The denominator is 12 over 7. The reciprocal of 12 over 7 is equal to 7 over 12. We multiply the numerator by the reciprocal. Cross cancellation? Yes. 18 and 12 are both divisible by 6. 18 divided by 6 is equal to 3. We cross out the 18 and put a 3 next to it. 12 divided by 6 is equal to 2. We cross out the 12 and put a 2 next to it. 35 and 7 are both divisible by 7. 35 divided by 7 is equal to 5. We cross out the 35 and put a 5 next to it. 7 divided by 7 is equal to 1. We cross out the 7 and put a 1 next to it. We multiply across and get a resulting fraction equal to 3 over 10, and this is our answer. Anyway, that is it for this lecture video. I leave the problems for you to try. I'll post the answers at the start of the next video. If you found the content helpful, please help me continue to grow this channel by hitting the like button, subscribing if you haven't already, and sharing this with someone who might also find this helpful. I'll see you on the next one.